This next video is only a small extension on what we just did. So we are going to be taking these zeros and writing them as a product of linear factors, but the question won't say write it as a product of linear factors. So I just really want to point out, right, if you look at this question, it says write the following zeros as a product of linear factors, whereas down here the question says find a polynomial function of degree 3 with the given numbers as zeros. What that means is that you're not allowed to leave it as a product. You have to actually multiply through. So I won't make you do these with too many zeros. It's kind of painful to multiply through 5 linear factors together. But your first step is going to be the same. So we are going to write this as a product of linear factors. So you're going to have x plus 5. Then you're going to have x minus root 3 and x plus root 3. Now the reason they ask you these questions is they really want to show you what happens to your polynomial function when you have these irrational or imaginary zeros. So the first thing we're going to do when we multiply through is we're going to multiply these two together. Now what do you notice about these two linear factors? When there was a zero of root 3, there always has to be another zero of negative root 3. Because when we multiply these together, what's going to happen? Well, we have x times x is x squared. X times root 3 is root 3x. Negative root 3 times x is negative root 3x. And then negative root 3 times positive root 3 is negative root 9. When I go to simplify, you'll notice that I'm left with x squared. Oh yeah, it was a difference of squares. Two conjugate brackets always multiply together to get rid of the middle terms, and I'd be left with x squared minus the square root of 9, which is 3. Now, this isn't actually a difference of squares because 9 is not a perfect square, but it does factor like a difference of squares. So x squared minus 3 can factor to x minus root 3 and x plus root 3. And then finishing this off, they just want you to multiply these two brackets together. So I would end up with x cubed minus 3x plus 5x squared minus 15. That squared came out a little funny, right? So I did x times x squared, x times negative 3, 5 times x squared, and 5 times negative 3. And then I would just make sure that it's written in descending orders of power. So x cubed plus 5x squared minus 3x minus 15 would be my polynomial function with a degree of 3 because I started with 3 linear factors. All right, and then I put one of these and I put it in the note so I could help coach you through it, because how the heck am I going to multiply this through? So I've got f of x is equal to, my first zero is nice, x equals 1, my factor would be x minus 1. And then we've got this guy, so it's going to be x minus 1 plus 3i. And again, you can get that by doing x minus that bracket. Or you can think if x was equal to 1 minus 3i, when I bring them over to the other side, it's going to be x minus 1 plus 3i, whatever works, right? Then my other bracket is going to be x minus 1 minus 3i. And then again, just like the one before, you always want to multiply what we call these conjugate pairs together first. So we're going to multiply this through. Now it's 3 terms times 3 terms. So we're just going to go through and do it. We've got x times x, which is going to give me an x squared. I have x times negative 1, which is going to give me negative 1x. I have x times negative 3i, so it's going to give me negative 3ix, or negative 3xi, whatever you want to write. And then I'm going to multiply the negative 1 through. Negative 1 times x is negative x. Negative 1 times negative 1 is plus 1. Negative 1 times negative 3i would be positive 3i. Then I've got 3i times x, so I've got plus 3ix. This is painful, hey? 3i times negative 1 is negative 3i. And then 3i times negative 3i is negative 9i squared. Holy, I will not make you do a lot of these. But this is proving to you, even when we get a zero like 1 minus 3i, you're not going to be able to tell from your polynomial function. So the next thing we're going to do is collect like terms. We've got an x squared. Awesome. I've got a minus x and another minus x, which is going to give me a minus 2x. I'm really hoping I did not make any small mistakes here. Then I've got a minus 3ix and a plus 3ix. Oh, sweet. I've got a plus 1. Okay. I've got a plus 3I and a minus 3I. Oh, sweet. Then I've got this minus 9I squared. If you remember from the beginning of chapter 3, I squared is equivalent to -1. What happened? All of a sudden, when I multiplied these together, everything that made the answer imaginary canceled out. And I'm left with x minus 1 times x squared minus 2x. And then I've got plus 1 plus 9 is plus 10. There is no indication in this quadratic factor that the answer is imaginary. And yet, if I was thinking about what we're going to do next, which is factor polynomial functions with complex or imaginary zeros, you'll get to a place where you're here and then your quadratic won't factor and you're going to have to use the quadratic formula or completing the square, and you're going to end up with this answer of 1 minus 3i and 1 plus 3i. But there won't be an indication in the question. And of course, we have to finish this off still. We're going to multiply the x through. We get x cubed minus 2x squared plus 10x. Then we're going to multiply the minus 1 through, so we've got minus 1x squared plus 2x minus 10, which is going to simplify to x cubed minus 3x squared plus 12x minus 10. And I really hope I didn't make any small mistakes in this. I'm sure somebody watching this video will let me know and I'll have to re-record it, but ideally not. Ideally, I did everything right. Awesome. So good luck with this.